Good afternoon, everyone. I'm welcoming you to our workshop, Demystifying the Server Side. I guess everyone's had their breakfast and everyone's doing good. And yeah, like we have a very strict time constraint of 2 hours. So without wasting any of our further time, just let's directly dive into the workshop. So again, I'm welcoming you to the workshop that is having a title, Demystifying the Server Side. There are many complex terminologies that will be simplified in the course of next 2 hours. So stick with us and we'll take you to the right to the server side. So before we start the workshop, let me introduce you to the team that will be delivering the workshop. So on your left is Harsh. He goes by Twitter handle RootXHarsh. He is an application security engineer at Vimeo. In center, it is Rahul. He goes by Twitter handle I am Noob. He's also a security engineer at Emirates. And on the right hand side, it is me, that's called Rajanish. And I'm a software security researcher at Zenith Labs. And the most interesting part about this is all three of us are in three different cities right now and two different time zones. So the online version of Ekoparty has made it possible for us to collaborate and present this workshop to you guys. So we're very thankful for this platform. And yeah, without wasting off any of our further time, let's dive into the workshop. So what's the agenda for today? As I told you, this workshop will deal with everything that will be around server side. So agenda for today is learning, and lots of learning. So we'll start with a workshop. It is again divided into 4 parts. That is SSRF, XXE, RCEs, and reverse proxies. So we'll start with making the cloud rain. Then we'll be exploring the file system with XXEs. Then we'll be nailing the shells with RCEs. And then we'll have a very good look into some very less discovered or less talked about content, that is the reverse proxies. So yes, guys, this is our layout of our workshop. And these are the 4 topics that we will be covering during our workshop. And yes, so before starting with the actual topics, let us first discuss what is server side. So I'm sure all of you might be aware of what a server side technology or server side terminology is. But just to reiterate, client side and server side technology or client server side terms are used by web developers, hackers, researchers, anyone who's developing with web application or mobile application for that matter, to describe the term where the application code is running. So if something is termed as server side, this means anything that is happening on the server side. So what does the server side contain? So mostly the server side contains all the business logic, anything that has anything to do with the database interaction, authentication, or any complex logic, file transformations, anything. So if there is any complex logic implemented in an application, it will be mostly running on the server side. So this is what server side means. And why is server side so serious? And why have we taken and started this workshop? So server side is serious because in the past, there have been multiple breaches, that is Capital One and Equifax, that were victims of some successful exploitation of a server side bug. So in case of Capital One, there was an SSRF vulnerability that was exploited to reveal the contents of the organization and to create a massive data leak. So that's why, a successful exploitation of a server-side bug could allow an attacker to disclose a lot of information, plus move literally inside the network and cause a huge loss. Unlike a client-side bug, server-side bugs are comparatively interaction-less. That's why they don't require any user interaction, and the severity is really high. That's why we are interested in server-side, and we are looking at the server-side bugs. So that was our basic introduction why we were talking so much about server side. Now, as a workshop is dealing with everything that has to be identified over the internet, that is by using an URL, we need to understand what an URL is. So according to the RFC definition 3986, this is what an URL looks like. So these are the few components that make up and form an URL. And this is how an URL should look like. So an URL contains a scheme, an authority, a path, a query, and a fragment. So scheme is basically protocol that is being used to interact with a service on the internet. Authority is basically the domain name or the subdomain name with the port. So domain subdomain name with the port forms the authority part of the URL, and which is again followed by path, which exactly points out where the location has been, where the resource has been placed on the server, and then it is followed by query and fragments. There's one interesting part that is not mentioned in this is there's another authentication part that is user password before the authority section. So basically before the authority part, there is another part that is also called as authentication that is in the format user password at the rate and then the authority. So these are the different types of URLs and this is how it looks like. So as I told you, there are different schemes that can be used. So schemes are basically the protocols. So here are a few examples of HTTP protocol based URLs, and here are a few file scheme based URLs. So yeah, this is pretty much it about URL. And we'll be talking a lot about URLs and how they can be used inside our different attack vectors in our future slides. So that was an introduction before we start on to our main topic. So as we are again like in a time constraint, so we've removed a lot of obvious things, but we tried and made sure that all the interesting part in this talk is kept intact and we'll be covering it thoroughly. So the agenda for today in the SSRF section would be introduction to SSRF, a brief introduction, as SSRF identification and impact, SSRF attack scenarios, and there'll be few real life interesting case studies that are non-trivial and have been discovered by Harsh in his real life engagements. So what is an SSRF? So SSRF is a web security vulnerability. It stands for server-side request forgery. It is a vulnerability that allows an attacker to interface with a victim server and make it issue a request on its behalf. So how can we put it actually in words? So if you could see the image on your right hand side, there is a web server, there's a victim server, and there's an attacker. Attacker is directly trying to access the contents that are there on the victim server. But due to network restrictions in place and firewall in place, the attacker is not able to access contents that are present on the victim server. So the attacker identifies a web server that has access to victim server somehow. So it could be some internal service running behind the web server or some internal infrastructure that web server has access to. So the attacker finds an SSRF vulnerability on the web server and makes the web server trigger a request on behalf of the attacker. So successful exploitation of web SSRF vulnerability on the web server will make the web server trigger a request to the victim server and read the response at the attacker's end. So a successful SSRF exploitation gives an attacker access to internal resources, metadata keys, and even the files hosted on the web server itself. So we'll look at it in the future slides. So this is a basic, simple example of how an SSRF vulnerability would look like in a pictorial decryption. So looking at SSRF, this is how SSRF vulnerabilities look at when you look into details in the code. So here we have two simple examples of a PHP code and a Ruby code here on the bottom right corner. So the PHP code and Ruby code both take in URL as input. So let us consider that the URL are user control parameters. So in both the cases, we can see that in PHP, file.getContents is used to fetch the contents of the URL and display it back in the application. In the Ruby code, we see that there's open call that fetches the content from the URL and displays the response in the application itself. So in both the cases, there is no restriction or no blacklisting, whitelisting in place. So anything that is being provided by the attacker or by the user is directly fetched and displayed back to the user. So in this case, if an attacker on the user tries to access a local resource that is on the system, for example, file etc password on a Linux system, he will get the contents of file etc password directly displayed on his response. And hence, this would be a successful exploitation of an SSRF vulnerability. Same in case of Ruby code, if the URLs are taken without any filtering or without any scheme validation, the attacker can input any resource and get access to it in the response. Also, There is another interesting vulnerability that we will be talking about in the future. But if any one of you is able to spot it, please keep it to it or enter it in the chat. And because there's another interesting vulnerability that is not SSRF, but again, it's a server-side vulnerability. So we'll be discussing about it in the future section. So now we have seen what an SSRF vulnerability is. How does it look on the code level? This is what it looks. Sorry. This is what it looks on the request level. So here is a simple example of a post-based request that takes image API uh, as an URL argument and fetches the image that has been passed into image API. So what happens here is, again, like this application is vulnerable to SSRF, we know that. And as this application takes in the image API as the image argument, this can always be replaced with some sensitive file path on the local system. So for exploiting it or looking through the SSRF scenario, what as an attacker or a bug bounty hunter or the researcher we would do is we would try to interface it with some local file sensitive file path on our system. So we'll try and access anything that is there on the local system and try and fetch it. So as the application doesn't validate the extension or the content type, it will just return us whatever is requested. So we have a simple example of it. We have created labs for this, and we have simple example of it that we would be looking at. So this is a simple file image fetcher URL that we are looking at. So we have created it as a vulnerable one. So we know that if we enter an image, it will fetch and show us the image in the response. So this is the functionality of this. And there is a backend code that does this for us. So if we look in the response, we can see that there is a data that has been returned in the response that is an image, and it is a base64 encoded blob. What happens if we try and change this data to something else? So I'm sure like the backend code is there, and as it is vulnerable to SSRF, it will just parse whatever we try to make it issue a request to. So in this case, this application is being hosted on DigitalOcean. So there is a thing called metadata API that is something interesting to look at when you're looking at SSRF. So when we try and access the metadata API of DigitalOcean, that is on 169.254.169.254, we get some response. Yeah, so here you can see there is no response because it was not an image. So the application doesn't process an image. But if we look at the response that is received on the network tab in the browser, we see there's a base64 encoded blob. And what we do is trying to decode the base64 encoded blob, we can see that it contains the information about the metadata API. So this is one of the scenarios where you can come across. There'll be a lot of image fetchers that will be in the applications that you will be assessing. So if you come across something like this, always go and try ahead for accessing the metadata API or local resource for that matter, and see if you're able to access those resources. So as I told you, like this was a simple example of an SSRF vulnerability. There are two main types of SSRF. So the one that we just saw is an example of full response SSRF. And there's another kind of SSRF that is called blind SSRF. So what happens in full response SSRF is that the response is directly visible in the response tab, like it was for us. Only it was base64 encoded, but it was directly visible to us. But in case of blind SSRF, the response is not visible, but there's a time difference or time delay that comes into place based on if the service is running on that port or not. So this can help us identify if the service is running in the background or not. And based on that, we can identify if the service is running. So that was a basic introduction to SSRF, and we talked about a simple SSRF scenario. So we always have to, try and escalate a vulnerability to its maximum impact. And when it comes to SSRF, what is the maximum impact that we can think of? So there is one thing that we can do is we can try and read the files on the local system. Yeah, that is one thing. We can try and pivot inside an internal network. Yep, that's another thing. But what is the maximum impact that we can try and escalate an SSRF to? So now as we know that everything is hosted on the cloud, And as with cloud, there comes metadata APIs. So AWS, Google Cloud, DigitalOcean, everyone has their own metadata APIs. So what does a metadata API contain? It contains access keys, secret keys, private keys, and everything that's related to the environment. So a successful exploitation of SSRF and reading of a metadata API could result in a successful remote code execution vulnerability or command execution vulnerability for that matter. So whenever you are assessing an application on AWS or Google Cloud for that matter, always see if you find an SSRF, are you able to access the metadata API? So when you're assessing an application that is being hosted on AWS, always try and check if you could reach the 169.254, 169.254 slash metadata and meta.google.com for the internal for Google Cloud if you have a successful SSRF. So this is something you should always look for. And there'll be a successful example that Harsh is going to demonstrate in his case studies that he came across in real life engagement. And this is something that is non-trivial because this wasn't found in an URL parameter. So let's go ahead and ask Harsh to show what he found. And on to you, Harsh.
Thank you, Rajanish. Give me a moment. All right, I assume everyone can see my screen. Okay, so let's get started. So Rajnish has talked about SSRF and some basics of SSRF, how we can find it, how. We have talked about SSRF and how we can find it and how we can escalate it. We will go ahead and see some. Everyone can hear me, right?
Yes.
Thank
yes,
you.
Harsh, now we can see you.
Yeah, sorry about the trouble, some microphone issue. Now that Rajnish has talked about the SSRF and how we can find it and how can we escalate it to some level of like accessing cloud metadata APIs and accessing file system files. Now we will go ahead and have a look at some real world case studies to understand SSRF in more details. So I will start off with before I join them. And it is a really interesting one, and I do have a write-up on it as well, but here I will show you how I approached it and how. Let's get started. So like any bug bounty hunter, how I see bug bounties is as that I want to, understand the business logic and, uh, try to understand the application feature and functionality. And so Vimeo provides this API playground feature where the developers are allowed to interact with their REST API endpoints. And the purpose of this API playground is to have you simply interact with the API playground, and you just have to select an API endpoint, pass the required path, query, and post parameters, and just click submit. And behind the scenes, it will make a post request to this endpoint slash API slash playground, and it has some interesting parameters to it like URI and method and params and segments. So looking at all this, I started assuming like what it could be doing here. So my first guess was that it is making a request to api.vimeo.com path for the API is taken from our side. So that is the path we give in the URI parameter. So suppose the path is slash users slash curly braces user underscore ID. It will become slash users 12345. So where this 12345 come from? It is within the segments parameter, and we define the user ID value here. So this is actually acting as a anything we define within the curly braces is acting as a variable or as a placeholder whose value we define within the segments key. So so looking at this, I was quite sure that they are making a server-side request with our control path. So what I did, I just simply say, change this to something else like any other path on the REST API playground, and that actually didn't work. It gave me a 403, and uh, what it means was that they actually allowed only selected endpoints to make requests to there was like only users endpoint or videos or albums, only selected whitelisted endpoints. So I cannot make requests to arbitrary endpoints, and that was I wanted to do, because if I could do that, I can think of further chain. So like I told, we have another input in here, that is user ID or video ID, whatever we define here actually will be passed using the segments key. We define its value here in the segments. So it is acting as a.
¿Y ahora cómo te despertaste?
Excuse me. Yes. So
Chicos, hay un micrófono abierto. Por las dudas, aviso. I'm sorry, guys. Keep going.
Yeah. Okay, so we have this user ID where we define value, and it will be passed on to here within the URI. So we cannot change, the URI because it will result into 403. But we can change this. So you might have heard about // which allows us to get a directory back or a path back. So that's what I did. I passed in a // here. And if it is not URL encoded by the server, like if the application is not URL encoding this part, it will be placed as in here. And when the HTTP library actually parses it, it will become it will go one directory back, and I would be able to hit another endpoints. So that was my guess, and I did that. So what I did was, I was in user ID, videos, and videos ID. So within the videos ID, here videos ID, I passed 4 directory back, and I was able to get at the root of the api.vimeo.com. So here is the response of the api.vimeo.com root. So that's how I was able to hit another endpoint on the API. Now, the problem was we are still on api.vimeo.com host. We can make a server-side request to api.vimeo.com host, but we cannot escape it right now. So what we do, we find an open redirect. So if I make use of an open redirect, I could force the server to, follow, if it's following redirect, and which it was, and if it followed it to an internal host that is maybe a metadata API, and Vimeo works on Google Cloud Platform infrastructure. So in this case, GCP metadata API, and that way I would be able to access their metadata API. So what I did, I started content discovery on api.vimeo.com host, and I found this really, really interesting endpoint that was /m, and anything you pass after that will be redirected to vimeo.com/anything. And this way I would be able to, now find an open redirect at vimeo.com, because it's not easy to find an open redirect on api.vimeo.com host, because it's an API, not a web application. And while vimeo.com is a full-fledged web application, and we have a more chance of finding an open redirect here. And by this time, I actually was working on Vimeo's program from quite some time now. I had plenty of open redirects in my bucket, which I didn't report because generally they are very low severity, and I don't generally report them. I changed one of them here, so that will become something like that. //am, and this path to open redirect is actually on vimeo.com, and I was able to this way redirect it to my control host. So the final payload looks something like this. We are in 4 directories, so we go 4 directories back, then am, and the vulnerable open redirect API endpoint on vimeo.com, and the host we want to make request for. So Doing this, and I was able to get a request from server side to my control host. And to my surprise, it was actually reflecting back the response. If it's a JSON response, like it will pass the JSON, and that way we will be able to get response back from the server. So I started fuzzing around it, and I found that uh, Google metadata API actually allows us to get response in JSON by passing this parameter alt is equal to JSON. And I just hit on on this internal host, and I was able to get the service accounts access token. So that was this access token, and this access token was actually very escalated. Like it has more than required permissions. It could allow me to attach my SSH public key to not just the instance behind, but rather the Google GCP project, Google Cloud Platform project. So it had multiple instances, and one of these instances was actually having a public SSH port. So now I can just SSH into it. So that way I was able to get a remote code execution. So using like having a partial control on URL and chaining it together with an open redirect, which otherwise would have been paid $100 or more than, not more than $300, is used here to get a $5,000 bounty and a code execution on the vulnerable server. So that's how you should focus at the SSRF. It's not generally just looking at URI parameters, but thinking what could be happening on the backend, how the application is processing your data. It might be making a request to the server side. So that was about it. Now we will look at another really interesting case study where I bypassed mitigations of SSRF, and it was really interesting. So let's get into it. So again, let's familiarize you with the application, give you a bit context of it. So this application provided me with a lot of integrations, such as WooCommerce store, and this WooCommerce store actually took our controlled URL, and it made a server side request to it. But the thing here was that it was adding a prefixed path to it. That is this. So this could be bypassed, by adding a query string or a URL fragment. But the other thing here was uh, that it was only allowing me to make requests to HTTPS hosts, not just plain HTTP. And I could theoretically, point it to my control HTTPS host and redirect it back to an plain HTTP. But again, that was also not working. It was again getting checked with this HTTPS function, and it made sure that the request they made it to is an HTTPS host. And finally, it was reflecting its response back in here. So the raw response will be written back to the client. So that was interesting. I started thinking about it, that there could be a potential SSRF here, but it is working on, we can, it is requiring us to make HTTPS only requests. So we cannot just hit metadata APIs of cloud platforms, because they generally work on plain HTTP. And that was the thing with this one. That we cannot make requests to metadata APIs because they on plain HTTP. We can, however, may find an internal host that is working on HTTPS. So that was the task. So before going into deep, I just passed this URL that was HTTPS myhost.com, and my host was actually pointing to an internal IP range, like localhost, for example, and it gave me that local IP ranges are not allowed. So they were on top of that, on top of the HTTPS check, they were also checking that it is not an internal IP. So what we could do here, we cannot make request to internal IPs. We need an HTTP host. So what we need is an company's asset that is hosted on, served on an HTTPS, that is by SSL, and actually points to an external IP, not an internal IP, external IP, but is only accessible using company's VPN. So that was we were looking for, something which points to an external IP and is only reachable through their VPN, not by any public internet. So I started doing some subdomain enumeration on the company's domain, and I came across this corp.company.com, and this was really interesting because corp and dev and other DevOps, these are generally interesting keywords because they are made for their corporate infrastructure. So I started brute forcing within it, and I came across multiple hosts within it which were pointing to either internal IPs or external IPs, and these were not reachable. Like they were required to be accessed over VPN. And this is exactly what we were looking for, because now, they point to an external IP, and if they had some kind of blacklist there for resolving, we can bypass this using this. So one of this host got my was jenkins.co.company.com. So I passed it into the WooCommerce URL, and I was able to get its response back. So this was Jenkins response. And why Jenkins out of all other hosts? Because Jenkins is a continuous integration tool, and it continuously works with production server. So it makes sense to it have been in the same VPC and make communication with production server. And because developers generally work with it, it makes sense to have an SSL here. And it is a critical part of any infrastructure. So that's why I went for the Jenkins host rather than any other. And this is how we bypass this simple SSRF, or you should say very very limiting SSRF to get a response of an internal host. So what are the key takeaways here from as a bug bounty hunter and as a security engineer? So blacklist can always be bypassed. So as a bug bounty hunter, if you figure out that there's some kind of blacklist, don't give up on that. You will end up on bypassing it. And as an engineer, please don't implement blacklist. That's not the way you fix SSRF. And finally, that VPN only host should always be in your mind when you're testing for SSRF, because generally, if there's some kind of blacklist, this could be used to bypass it. And lastly, as an engineer working for application security at your employer, you should make sure when you are interacting with third parties, you make use of network segregation. Make it in a custom VPC, or just segregate that network so it cannot hit your infrastructure, a critical infrastructure part. So these were some key takeaways from here, and now we will see some XFC, exploring the file system. So on to you, Rajanish.
Thanks, Harsh, for beautifully explaining the SSRF vulnerability, and also our participants would have had a very good insight about some typical and non-trivial techniques of discovering an SSRF. So guys, what we would like to highlight in this point is just try and keep looking and digging in and understand how the application works in the background, because there might be places which is non-trivial but still vulnerable to very critical vulnerabilities. So thank you, Harsh, for explaining it beautifully. And now let's go ahead and start with the second part of our workshop. So that's called exploring the file system with XXE. So the agenda for this is XXE and XML basics, then ways to exploit XXE, that is the known techniques, that is in-band XXE and out-of-band XXE technique. Then the problems or limitations that we have with the existing XXE techniques, and then using the local DTD technique to read the file system, which is something really interesting, and you should look out for it, because this is not something that is very much talked about. And let us just directly go ahead and get into it. So basically, this XXE vulnerability is not so much talked about, and it's difficult to find in the wild. But if you know the basics right, and if you know how the application is working and parsing the documents, it's always easier to understand and exploit it if it is vulnerable. So before we start on to XXE, let us first understand what an XML document is and what is the reason for XXE to be present in the first place. So XML is basically, it stands for extensible markup language. So it's a well descriptive and a well structured document. I'm sure you would have always come across it when you were fiddling with requests. So there's always a post body that has XML body into it. So it is used to store and transport information, and it's also used as part of data sets. So the schema for an XML body is been defined into the doc type element that is part of the XML document. And XML parsers are the ones that fetch the values out of the XML body that are present in the body and process it depending upon the business logic. So these are the few things that we should keep in mind. So before we start on to XXE, again, as I we should understand what an XML document is and what are the different parts of it. Because the reason for XXE to exist is the things that XML definition allows us to do, and we are basically exploiting the specification that XML definition allows us to do. So basically, an XML document has three main parts. That is the XML declaration, the doc type definition, and the actual XML body. as I told you in the previous slide, the DTD definition is basically the schema for the actual XML body. So the DTD definition defines the schema. It has elements, attributes, data types, etc. So you can see there's a user's root tag here, and there are different attributes to it, which have been defined by a doc type definition. The XML declaration is basically optional thing, and it defines the cat set and the language of the XML document, which is followed by actual XML body that holds the content, and it is basically the data carrier. So according to the XML document specification, the XML document specification also allows us to host the DTD, that is the schema, that is what we are talking about here, on an external site on an external endpoint. So a doc type definition can be used with the system keyword, and the DTD definition can be hosted externally. So in that case, we call it as an external hosted DTD or an external DTD. So here the entire document is basically the same as the last one, except the DTD is basically hosted on an external entity or an external system. So what is the advantage of this? So if the XML document is really huge, it basically hosting an DTD on an external endpoint helps us to shorten the length of the XML document or the size of the XML document, as you can see in this case, because this entire space over here has been avoided. So that was a bit about the doc type definition, which is the second part. Then there are XML entities. So what are entities? Because XXE is XML external entity. So we need to understand what an XXE, what an entity is to understand how XXE is being exploited in the first place. So to put into simpler words, the entity is basically a variable. Like in programming language, it's just like a variable. It's a way of representing data. So basically, there are three types of XML entities that are built-in, general, and parameterized. So built-in entities are the entities that are built into the document because of the XML specification. Like and-LT and GT are the entities that are built in the XML specification for less than and greater than tags. So if you use and-LT and GT in an XML document, it will be basically replaced by less than and greater than tags. So these are the variables that are or entities that are being built in by specification. So that are called built-in entities. So just like doc type definition, entities are also support the system keyword. They can also be summoned by using the system keyword defined using the system keyword and can be summoned inside the document. So there are basically three types of entities that I already talked about. So we'll look at the two user-defined entities, that is general and parameter entities, in a bit detail, because these are the ones that we'll be exploiting in the XXE scenario. So there are two types of user-defined entities, that are general entities and parameter entities. So what differs in both of them is the definition, like how we use the syntax that we use to define them, and also how it can be used and where it can be used inside a document. So here, as you can see, for a general entity, the definition is it is defined inside a doc type element foo. That's the entity followed by an entity name and the entity value. And the calling convention for an general entity is it can be called using and the entity name. But the only thing is that it can be called inside the XML body. Whereas in a parameter entity, the definition is almost similar, except we have an percentage tag. So entity followed by a percentage and followed by the entity name and the entity value. And the interesting part about parameter entities is it can be summoned inside the doc type definition itself, whereas the general entities cannot be summoned inside the doc type definition, and they can be only used inside the XML body. So this is the calling convention, that is percentage and the entity name for parameter entities. So now we understand there are two types of user-defined entities, that are general and parameter entities. So this is how it looks in a visual representation. So here, entity without percentage, it is a general entity, and it is defined using the system keyword, and it is fetching contents that are there on the username.txt on mysite.com. So basically, as I told you, that entities are variables. So anything that is being hosted on mysite.com username.txt will be basically held by the entity name. So whenever entity name is used, the username.txt, the contents of username.txt will directly get replaced in the name section here. This is a simple definition for a parameter entity. So here, as I told you, the calling, the naming, the defining convention, that is percentage followed by the name, has been done here. So it is a parameter entities. It is defined using the system keyword, and the DTD that has been hosted on external site is basically called here. And as I told you, that the special part about parameter entities is that it can be called inside the doc type element. So basically, we define external DTD and we call it inside the doc type element itself. So here is basic definition of how a general entity and a parameterized entity would look like in an XML document. So now we know what an XXE. Before we start, now we know what entity is. How does a XML document look like? What is the doc type definition? So now we are ready to understand what an XXE vulnerability is and how does it exist and how do we exploit it. So XXE, that is XML external entity, is also known as XML external entity injection. It's a web security vulnerability that allows an attacker to interface with the application's XML parser. So the XML specification contains some dangerous features, and these features are being exploited to make the application or the parser do things which it is not intended to. So the functionality of an application parser, that is the XML parser, to allow, including the external entity, allows an attacker to make sure that make an external request and get the content out of it. So a successful exploitation of an XXE vulnerability would allow an attacker to read the contents of the local file, to perform an SSRF vulnerability, and yeah, so it could be escalated into multiple things, as in I will be looking at in the future slides. And yes, so a successful exploitation of an XXE vulnerability would allow you to make requests to an external party, read local files, perform an SSRF vulnerability. So there's a small cheat sheet that is being hosted on Security Idiots, which Rahul is an author of. So just go and have a look at it so that you get more insights about how we go ahead and exploit XXE. So now we know that, okay, there's a vulnerability that is associated with XML, and it's called XXE. So let us look at how it looks in terms of a request and a response scenario. So when you look at a typical XML request, post request, the content type for XML body, XML document is application/XML or text/XML. And this is something that looks like an XML body to us. So this is a login scenario that we are trying to imitate here. There's a username field and there's a password field. And if the right username password field is given, there'll be a successful login. But as you can see here, we have passed on a wrong password. The application doesn't allow us to log in, and the username field is displayed back in the response. So this is the kind of scenario that we would be interested in while looking at an XXE vulnerability. Because if something is written back in the scenario, in the response, we'll always be interested to replace it with an entity and see if the values are replaced back in the response. So when we go ahead and find such kind of functionality, what is the things that we should go through, or what is the things that we should try out to see if it is vulnerable to XXE in the first place or not? So as we saw in the previous example, that there is some value that is being replaced in the response. So what we could do is in the XML document, let us first define a general entity named something, admin, for example, and let us call that entity inside the body itself. So calling that entity that has been defined by us, that is a general entity, and calling inside the body, and let us see if the application processes it and allows entities to be there in the first place. If that works, what is the second thing that we can do? Let us see if the external requests or external entities are allowed. So after we see that, okay, the application allows a successful general entity in the first place, let us replace this entity with a system of public keyword and define an external entity that is pointing to a burp or an external server that is under a control. And when we pass this request to the server, to the XML parser, we see if the request is being processed by the XML parser and it allows external entities, there'll be a request that will be triggered to a burp collaborator endpoint. And this it proves that, okay, this application is vulnerable to XXE. Also, there are multiple parsers that parse document based on the content type that has been specified. So what is something that you can do is, if the application is parsing the JSON document, what you can do is try and change the content type to application XML, and then make a well-formed XML document and see that if the application parser parses it in the background. So if it is parsing on based on application type, content type, so there's a possibility that that parser can also be vulnerable to XXE. So there are 4 things that you can do, as I told you again. See, try and general entities in the first place. If it works, replace it with system a public keyword and try external entities. If it works, well and good. And if there are parts of that parse JSON document, try and parse XML document with it and see if it works. So yeah, like it is the same scenario that I was discussing in the previous slide. So this is a login form, and we have defined an entity using the system keyword here, and it is pointing to etc host on a Windows machine. So when we put a wrong password, the application throws an error with the username that, okay, this user is not a valid username, and the contents that are being hosted inside the XX entity that we have defined here will be displayed back in the application response. So this was the scenario that we were talking about. And this is how it looks when there's a successful XXE in the first place. So we've defined an XX entity that is pointing to etc host. And as we have entered the wrong password, application shows the username, and username consists the contents of etc host, and it is being displayed back in the application response itself. So this is a simple example of an in-band XXE, and we have labs for it. So we'll be sharing it across to you guys so that you can try it out with your own payloads and see if it works for you. And if you have any questions, just get back to us. So that was one technique of common technique of XXE exploitation. There's another technique that is called as out-of-band XXE. So in the first place, when you are able to read the response, well and good, you can always go ahead and read the response by crafting a well-formed XML payload and see the response from the document. But if you're not able to read the response in the first place, what you will do is try and exfiltrate data from the target server. So here is an example of the same XXE vulnerability, but here we are trying to exfiltrate data on the attacker's server. So this is the payload that we have constructed, and this is some complex payload. So let me go ahead and dissect it for you guys so that you'll be able to understand how does this exactly work, because it looks very complex, but it is not that complex. So this is the payload part of the XML document that we are talking about here. So as you know that XML document, it performs the sequential order of parsing. That is, it will parse the document line by line and till the end. So in this document, first let us see what is happening in the first line of the doc type definition. So we've defined the doc type, that is R, and we have an entity declaration that is a parameter entity SP, and it is pointing to a DTD that has been hosted externally on attacker.com xxe.dtd. So when this entity is called, that is SP, basically the values of this will directly get replaced here. So what are the values of this? So we go ahead and see what are the values at attacker.xxe.dtd. So guys, please follow the numbers so that you will be able to understand how this sequential execution is taking place. So we go to attacker.dtd. These contents, basically, that is the 2 entity definition, that is data and param, are being defined here. So these directly get replaced here. And the second line that will be passed will be entity data. So what is the entity data? It is a parameter entity again, and it is having the values of etc host inside it. Okay, so now data will have the values of etc host. Now the next line is again an entity definition, but here it is a string. As I told that entities can act as variables. So basically, it is holding the value of this string that is inside the double quotes, but the string actually looks like an entity definition in itself. So the third line is parsed by the XML parser, and param1 is having the values of this entire string here. So this parsing is complete. Now we come back to param1. So when param1 is parsed by the XML parser, this entity definition that has been here directly gets replaced in place of param1. So this gets replaced. So this is again pointing to another entity that is exfil, that is someone using the system keyword, and it is pointing to the attacker.com with the exfiltrated data. So this is the data that we wanted to exfiltrate that has been attached to the attacker server using the FTP protocol. And when this entire doctype element parsing is complete, the body is parsed and the exfil is called, and the data is being exfiltrated from the victim server. So yeah, this looks a bit complicated, but if you totally understand how things work in the background, it is very easy to make a well-formed XML payload. The reason why we use FTP here is from Java version 1.5. The Java version 1.5 doesn't allow us to include illegal characters, that is /r/n in the HTTP request. Sorry. So the contents of /etc host has a lot of new line and spaces. So we need the /r/n character. That's why we use the FTP convention in here, and the FTP scheme is used to exfiltrate the data. But in the latest version of Java, what we have seen is even the FTP doesn't allow passing of /r/n. So what happens in that case? So we're not able to exfiltrate data. So this is an interesting scenario. So where a new technique, that is an interesting technique again, that is called as file not found exception error technique, can be used to read the response in the application response itself. So for this thing to work, we need to see that Java has allowed server errors enabled. So we have server errors enabled on the target machine so that we can generate an error purposefully and add the contents of our exfiltrated file in that errors. So the entire payload remains the same, except in the final entity definition, we are pointing to a file related to the server path, which is non-existent. So this file 4 times x is not existent on the server. So when XML parser tries to parse this file or tries to fetch this file, the server would return a response that is file not found error with the contents of the data that is our exfiltrated file. So this is another interesting technique that you can use while looking into XXCs for that matter. So this is the file not found exception that has been raised by the server, and we have read the contents of the file that we wanted to read. So we have a quick demo of this that I can show to you guys. So this was the username and the password thing that I was talking about. So if we have a look. So this is how this XML document looks like to us. That is the login request. So there is, again, a simple login request that I have already captured inside my repeated tab on the verb. So as I told you that I have defined XXC with system keyword, and it's pointing to file etc password, and I'm using it here in the first place. So if I use like some non-existing user, so the application is basically giving me a message with that non-existing username. So what I did here was again just replace it with the entity that I have defined, as I told you in the methodology before, and we can see that it basically parses this entity definition and gives us the contents of the file that we are trying to parse. And the file not found exception, again, like what we were talking about, is we hosted a DTD that is hosted on pastebin.com. So I could show you here. So this is how you host a DTD externally on some place. So if you don't have a server, you can always go ahead and use the pastebin to host your DTD. And this is what we have done here. And in this case, we are trying to point it to the file that is non-existent. This test file is not existent on the server. This was the XXX file that we were talking about here in this case. So when the application parser parses that file, the file is not there, and it is basically appended with the contents of /etc password with the file not found error. So there's a big chunk of error that has been displayed, plus the contents of the file that we wanted to read. So this is one interesting technique that you should always look out for when you are trying to exploit XXC successfully. So the reason why we hosted some people would have a doubt that why did we host this entities externally? So according to XML document definition, we're not allowed to call another parameterized entity inside a parameter entity definition itself. So if we use this inside this and define it like this, there'll be an exception raised that we're not allowed to use data entity inside a parameter entity definition itself. So that's why we had to post this externally on Pastebin or any attacker server for that matter. So this was two different types of techniques that you could come across. So this is something that, when external requests to your external hosted DTDs are allowed. But what if there are no outbound requests allowed? So Rahul will come and explain some interesting technique that is the local file DTD technique that will enable us to read contents even if there is no external or there is index fielding allowed in the first place. On to you, Rahul.
Sure thing, Rajanish. So can you guys see my screen?
Yes.
Okay, great. So thank you, Rajnish, for explaining the XML basics and some common techniques that we use to exploit XXE. So we had a look at what inbound XXE is in case when we are able to retrieve the contents of the file that we want to read on that vulnerable server. In the response itself, it is inbound XXE. And in case we are not able to retrieve the content in the response itself, we go for out-of-band technique. So in out-of-band technique, we are basically exfiltrating the data or the file that we want to read over the network to the attacker controlled server. But what if there is an egress filtering there, which means that your out-of-band HTTP requests are not sent out from the target's network. And if you put your burp collaborator URL in the system keyword, you would notice that there is no HTTP request, but only some DNS queries are made. So in that case, it means that we cannot host our or use our externally hosted payload. And we know that from this slide that it is really important to host our payload somewhere because we cannot use it in the same XML document because of few limitations. Okay, so let's see how we can tackle this situation. So even though there is an egress filtering, let's say there could be some whitelist which is applied to some of the domains or subdomains of the organization. So let's say if you find a domain which is whitelisted to send out-of-band HTTP requests to, and you could find an unrestricted file upload on them, and then you could upload that same XXE DTD file that you were hosting on your attacker server to one of those whitelisted domain or subdomain, and you could use that in your XML payload. But that file also have to be accessible unauthenticated. And another thing that you could do is you could find unauthenticated SSRF with full response control. But both of these two cases are actually quite unlikely to happen. And therefore, we have got this third technique, which is local DTD technique, which can help you exploit XXE in worst cases. So let's have a look at what it is. So when you install certain softwares, they create a lot of DTD files by default when they're installed. So for example, if you install XAMPP on Windows or maybe a fresh installation of Windows, some packages on Linux, they drop a lot of DTD files by default when they're installed. So what we're going to do is basically utilize this already existing DTDs which are on the target's file system, and we are going to somehow overwrite some of the parameter entities in those DTD files which exist on the target file system, and we would see how it actually works in the further slides. And finally, we are going to use the same technique which we use in the file not found exception one. And for this technique to work, again, the server errors have to be enabled. So let's look at the case study of this local DTD technique, which I found in few of our bug bounty targets. Okay, so the first thing to exploit this local DTD technique, XXE using this local DTD technique, is to identify the software or the web server or the platform which the application is running on. So to do that, once we have identified that there is an XXE, what we could do is we could use the simple the inbound XXE technique, and instead of referring to a existing URL like to a file or a external URL, what you could do is you could supply a non-existing directory. And what would happen is when XML parser tries to parse and load this non-existing directory, it is going to throw a file not found exception. And in the file not found exception, you could see that it was trying to load this non-existent directory relative to the server's path. And from this full path disclosure, you could identify two things. That is, your target server is running on Linux and it is running on Tomcat web server. Okay, so equipped with this information, what we are going to do is we are going to install a local copy of this identified server, which is Tomcat in this case. And then we are going to look at some of the DTD files, which comes along with the installation of this Tomcat web server. And Go Secure team have listed a few DTD files, which are present in some very popular and common applications. So in this particular file on the repository, they have listed a few jar files which contains DTDs and which are related to Tomcat. So this JSP API.jar and this Tomcat coyote.jar is something which contains a few DTD files inside them, which comes with fresh installation of Tomcat. So what we're going to do is, based on this local copy that we have installed, we are going to look if we could find these jar files somewhere. So to do that, we simply run a find utility to find all the files which have jar extensions in the Tomcat installation directory. And we could see that we were able to find JSP API.jar and also the other one. But let's just stick to this one for the slide. Okay, so now we have confirmed that this JSP API.jar file exists on our local installation, but let's also confirm that if this file also exists on the target's file system. So what we are going to do is we are simply going to use the file scheme and put the absolute URL to that jar file. And as you can see that there was no file not found exception thrown. And there is some failure, which is probably because of wrong username and password, but no file not found exception, which means that this jar file actually exists on the target server. Okay, so on the top right corner, as you can see that this is the state of the XML payload or the XXC payload that we're building, and it would keep on changing as we move further. And so keep an eye on it. And next thing is that this jar file actually is nothing but an archive. So you could simply extract it. It is similar to a zip or RAR, you could say. And coming back to this image, we see that after this jar file, we have a location to a DTD file after this exclamation mark. So let's just extract this JSP API.jar file on our local installation. So when we unzip this jar file, we find that this exact same path to this DTD file, which is Java X servlet JSP resources and JSP XML.dtd, exist inside your JSP API.jar on your local installation. So now we have to somehow access this DTD file inside the jar archive and check if that also exists on the target server. So to access a file inside a archive, what we can do is we could use jar protocol. So this jar protocol is available in Java-based servers, luckily, and the syntax goes something like this, which is jar followed by the protocol, which could be HTTP or file, let's say, then the absolute path to the jar file, followed by an exclamation mark and the relative path to the file or the resource that you want to access. So in this case, we wanted to access this JSP XML.dtd, which was inside Java X servlet JSP resources directory inside this jar file, which is JSP API.jar. So we could simply use this whole protocol and try to use it in the system keyword. And again, as you can see that no file not found exception was triggered, which means that this particular DTD file also exists inside the jar archive. Because otherwise, if you have passed something like non-existent.dtd, it would have given you a file not found exception because it was not able to find that file inside the archive. So once we have identified a DTD file, which was in this case inside a jar archive, what we are going to do is we are simply going to open that DTD file and look for two things, which is a definition of some kind of parameter entity, which Rajanish already explained what it is. And then we are going to look at if the same parameter entity is called somewhere else in the same file, in the DTD file. So we have got this parameter entity in this JSP XML.dtd here. On line 82, we see that it is defined and it has got some value, which really doesn't matter. All we need is the definition and it should be called somewhere else. So on line 89, we see that this same parameter entity body is called. So this value of this parameter entity body would be substituted over here. So this is all we needed for the exploit. So let's see what we are actually going to do. So now what we are going to do is we are going to create a parameter entity with the same name, which is body, in our XML payload, in our XXC payload. And what we are going to do is whatever value we put in our payload would actually be substituted over here instead of that one which was already there. So now what we can do is if I put something like this in my payload, which is parameter entity body with some value inside the single quotes here. So I have put in this value. So let's actually see what this particular value has to do with this payload. So we know that our input is somewhere here. So whatever we pass into our body parameter entity would be substituted over here. So what we are trying to do is we are basically trying to close this element tag here, and we are trying to balance this leftover closing angular bracket. So to do that, I have just created something test and closed this element tag. And then to close this final remaining closing bracket, I have created a fake entity with some name and some random value. So in between here, now we have full control over whatever XML content we want to put in. So everything that I write in between would actually be substituted over here, and our XML would be syntactically correct, and parser should not throw any kind of errors. So let's just summarize what we did until now. So we are first identified using a file not found exception that that the server was running on Tomcat on Linux, and we identified that there is a jar file which is JSP API.jar, which consists of a DTD file which was JSP XML.dtt, and we found that we could access this particular file inside the jar archive using jar protocol. We then found a parameter entity body which we could use in our XXC payload to somehow overwrite the content of this DTD file. So now what we are going to do is, instead of this v control here string, I'm simply going to use the same file not found exception payload that we were hosting earlier, which Rajanish showed you. So let's see how actually the full payload looks like. So this is what the full payload looks like. And as you can see that instead of this v control here, I have put in the same exact payload which we were earlier hosting it to the attacker server to leak the contents of the file that we want to read in the error or the file not found exception itself. With a difference that instead of using percentage, we are encoding it to its hexadecimal HTML equivalent. And similarly, to not mess up with the quotes and all, we are using this hexadecimal HTML encoding of single quote. And again, let me just reiterate what actually is happening. So in the first step here, we are trying to access this DTD file, which is actually inside a jar file. So we do this using the jar protocol. And this is referred by this parameter entity called XXE. In the next step, we have redefined this parameter entity, which exists actually inside this DTD. And whatever content we pass in is actually going to be substituted over in this DTD. So we actually balance this XML just to make this syntactically correct. And in between here, we actually pass the payload that we wanted using file not found that we saw in the file not found exception trick. And finally, we summon this XXE to load this DTD file. Finally, we are calling this eval parameter entity, which is inside the DTD file, which we have somehow overwritten, and which calling this actually defines this error general entity, and therefore we could call this. And what this error entity does, it is going to try to look for this abcxyz non-existent file, and followed by it is our parameter entity file, which is this one, which is pointing to etc password, and therefore you could see that it leaked the content saying that it couldn't find the file /abcxyz followed by the contents. So the idea behind this actually was that we cannot have nested entities, like we cannot have this file parameter entity being called inside another parameter entity. Now that was the restriction that we saw earlier, but the parser would not complain about this nested entities if we were somehow able to load this using system keyword by hosting it on our attacker server or something like that. But in this case, out of band requests were blocked, right? So what we did was we somehow overwrote the contents of the DTD file, which already existed on the target system. And therefore, we were still somehow loading it from different file, and it was not a part of this XML document itself. We were somehow overwriting the content, but we were loading it from the local DTD file. And therefore, we were able to leak the contents of the file that we wanted to read. And with such vulnerabilities come good bounties. So yeah. So let's look at some of the web application firewall bypasses techniques that we could use to bypass some firewalls. So the most common thing that is usually picked up by WAFs is the system keyword. So in case system keyword was blocked, what you could do is you could have used the public keyword. And how to use that? So for example, if you wanted to define a parameter entity, you could simply do entity percentage the entity name, and then followed by public keyword, and then a random text. It could be anything. The value could be anything. And finally, we have the URL. So instead of system URL, we could have simply done public, some random text, and the URL. So similarly for the general entity, we have got public, anything, any random text, and the URL. And another thing that we could do is we could add this encoding attribute to the XML declaration. And if the parser obeys it, we could simply encode our XML body to UTF-16, and WAF would not be able to detect it. And another thing that you could do is we could use such cryptic name for doc types or entities, and maybe this could help to bypass some WAFs. And another thing is that you could simply remove this XML declaration part. This is mostly optional, and most of the parsers would not complain about not having this slide. And also adding a space just before the protocol in case, WAFs are blocking protocols after system keyword like HTTP or FTP. You could simply add some white spaces before this, and it would still work and might bypass the WAF. And again, for Java-based server, instead of file, you could simply use netdoc protocol and do something like netdoc:/etc/password or whatever file that you wanted to read. And finally, we have different encodings that you could use. For example, we could URL encode percentage and ampersand. We could use the hexadecimal HTML encoding, and even like other than hexadecimal HTML encoding, we could go for decimal encoded version. So for example, for percentage, we could use this ampersand #37 semicolon instead of this hexadecimal version. So let me just show you quickly a demo. So this is an example of this exact same thing that I just showed you, which is local file DTD technique. So in this case, again, I'm doing the same thing, which is using the jar protocol to load this particular file inside this jar archive on the target machine. And with this body parameter entity, I am balancing this XML here. And in between, I have written the same payload, which I used in the file not found exception tag in OOP section, out of band section. And therefore, I was able to retrieve all the contents of the etc password. So similarly, we could also use all the same techniques that we saw in SSRF section. So we could again read the public keys or whatever is available on the metadata API using XXC. As you could see that I was able to read the public key here of my DigitalOcean metadata API. And similarly, to bypass web application firewalls, you could see that instead of using all this as a string, passing this as a string, I have simply HTML encoded it, decimal HTML encoded this, and it still worked, and it might have helped to bypass web application firewalls. So yeah, that was pretty much it for the XXC part. Now Harsh is going to show you how to nail the shell with remote code execution. So over to you, Harsh.
Thank you, Rahul. First of all, I want to make sure everyone can hear me right.
Yes, sir.
All right, so I will start. One second. Cool. So everybody can see my screen, and I'm starting with the RC part. All right, so we have talked about SSRF and XXC, and we have seen like we can extract metadata keys using XXC or SSRF. We can, one second. Yeah, we have seen how we can extract file system files or extract metadata APIs information. Now we will see how this can actually, talk about RCEs, like what is RCE and how we can achieve it using the same vulnerabilities. So we will keep it really basic, like just talk about in a bit and try to understand it using some real world case studies, because having real case studies is what makes it really practical. So what is an RCE? So like we talked earlier, we say an SSRF and say XXC. So just like them, it doesn't have a particular attack vector, right? It is not a vulnerability class in itself. Like the way I see is we cannot count it as a vulnerability class, but rather an end result of exploiting a vulnerability, such as an injection like vulnerability. Maybe you have an OS command injection or a server side template injection, where you will use file system APIs or spawn like process spawn of templating engine, and that way you will be able to get RCE. So exploiting an RCE could allow you to get a command execution on the server or code execution, and that's how it works. And sometimes like XXE or SSRF, it can be blind, so we will actually filter data over DNS chain as out of bounds. So this is the really basics, and we will try to understand the concept thoroughly using some case studies. So I will start off with a remote code execution case study using file override. So let's get started. So this was an enterprise level application, and it is a Python based application. So not just a PHP application where you can just upload the file and get an RC, right? And there was like when I was testing it, there was a interesting endpoint that was allowing me to upload any types of file, like any kind of extension to it. So within the file name attribute here, I started passing a full path like /etc/test.txt, and I got a 500 server error. And when we talk about when I pass /tmp/test.txt, I got a 200 OK response. So this was two really interesting behavior from the endpoint. So it seems like we do have a arbitrary file create here, like at arbitrary location, because as we know, /etc is a directory where not every user can write. It's certainly not a web server user, while TMP is a well-writable directory. So maybe it was able to upload the file here, and that's why it's served the 200 OK response. While in this case, in the etc/directory, we have a permission denied exception from the file system, and that's why we got a 500 server error. So having that in mind, I started going farther with this, and this was an enterprise application, and I hadn't idea of the directory structure, like where is the Python application running and stuff. So with that, there was a special route that was /static, and it served the file using home/app/static. So anything you add in home/app static will be served using that route, and that way I can confirm that I indeed have a file creation here. So I just uploaded my file into /home/app/static, and I made a request to that route with that file name, and I was able to extract it. So we do have a file creation here at arbitrary location with arbitrary extension. So with that in mind, I started digging more into the application. Right now, I do have an access, but it's a Python application. To get a remote code execution, I cannot just upload a Python file. If I were to re-upload or override the Python file, it would actually require the server administrator to restart the application, and that would not count as a remote code execution. That would certainly be a code execution because you need to have an interaction with admin, but we want to get a remote code execution. So I started digging more into other functionalities. Maybe somewhere I could change this. So while doing so, I came across this interesting endpoint where I was allowed to generate dynamic PDF that is reports, and it could have my content. And yeah, so I was playing with this endpoint, and it told me some interesting things in the output of the request. So that was cmd/opt/local phantom/js/ping/phantom_js. So it's like it's executing a phantom_js binary, and checking some arguments to it, one of which is a JavaScript file and some other arguments. Okay, so it seems like we have an endpoint that is when we make request to it, it executes phantom JS binary. Okay, so what if I make use of this file creation to override this phantom JS? So theoretically it should work, because now when I make a request to generate a new PDF, it will execute phantom JS with my code within that, and that way I could get a RC. But the problem was the file uploaded using this endpoint won't have an executable flag to it, and Linux will require us to have a executable flag to the file which we are executing. So when we are executing it, it will look if phantom just has an executable flag, and if we don't, it just won't work. We will get a permission denied. So it was not it was not gonna work. Theoretically, that's what I figured, and I just didn't pursue it, because if I just re-uploaded it, it would break the feature itself. So moving on to it, I found this second file that was op resources / xyz.js, and I took a moment to like what's happening here, and I started googling like what is phantom JS and what are its arguments. So what is phantom JS? So phantom JS is a headless browser, and it allows us to make use of OS level APIs within the JavaScript we pass to it. You can even spawn your own process or interact with the file system. So with that in mind, I had a theory that okay, what if I override the JS file instead of the phantom JS, and I spawn a new process and execute my command from there. So that's what I did. I went to the endpoint. I re-uploaded the /op/resources /xyz.js with this code that would require a child process, and we will call this spawn method, and we will pass our curl command and argument to it. And after that, we will just make request to the PDF generator again. Only this time it will executing phantom JS with our input in the xy.js, and that would lead to a command execution. So this is how I was able to get a remote code execution on the target application. Now, the thing here to notice is that we didn't have a particular approach or attack vector to get an RC, but rather which and multiple vulnerabilities to different features to get an RC. So that's the thing about RC, like you chain things, and you find that end result could be the compromise of the server. So we will see another case study such like this, and in which we will make use of debug mode of the application to get a remote code execution on the target server. So again, this application was I was hacking on this bug bounty program, and I was fuzzing around it because one of my given value was reflecting back in the response header that was content disposition. So I passed CRLF character, that is /r, and to see like if I could do a CRLF injection, and it threw me an exception of full stack stress, and this stack test actually had this secret token, and it was looking interesting by the name itself, like secret token, and it has a random string attached to it. So what it is, I started googling and figuring out what it is. So by just looking at Google, it was something that could allow me to sign my own cookies for this application, and this application was a Rails application. So before jumping into the vulnerability itself, let's try to understand how cookies actually works in Rails application. Okay, now we have a secret token that could sign our own cookies. Let's see how cookies actually work in Rails. So in Rails, we have this format for cookies that is base64-signature. The base64 part is the payload part, where the information you want to store. And you want to, of course, maintain the integrity of it, right? If you have an email here and you're doing an authentication based on email, you want to make sure people user don't able to alter with it. So you have a signature for that, and where this signature comes from, using that secret token. So we sign this payload using that secret token that gives us signature to maintain the integrity of this base64 part, that is the payload part. Okay, so now that we have a secret token linked here, we could make use of that to sign our own cookies and potentially make the application use some application feature to escalate some level of access. So but I didn't have much success there. So I looking more into it, what else I could do with this. And while doing further research, and I come across that Rails actually uses two serialization format for cookies. One is JSON and other is Marshall. So JSON you might be aware of, while in case of Marshall, it is rather unknown. So let's see what is Marshall. In Ruby, we have serialization deserialization format named as Marshall. So it is basically a fancy name for serialization and deserialization, marshalling and unmarshalling. And by default, up to in the older version, the version I was testing at least, Marshall used to be the default version for the cookie serialization. So if you have a valid Marshall within the base64 part here, it will decode the base64 and it will unmarshal it. That is, you can have your own object initiated. So I can sign my own cookies, and now I can certainly sign my own Marshall objects. Basically, I can send my own serialized for object, and Ruby will try to deserialize it. So I had an object injection here. So I started Googling like, okay, how I can lead this to an RC, like object injection to RC. So to my surprise, there was already some research done on this, and there was a gadget available to it that could allow us to gain deserialization to unmarshalling or deserialization to RC in a Rails application. So it looks something like this. This is a ready-made script by the researcher. So here's the Marshall data and basically the gadget chain. So we pass our command here, and which will be Marshall to here, and all this will be base64 encoded, and we will sign it using our secret token that will be saved here, and we will have that cookie in the same format payload part. That's the signature, that is digest. And so I passed curl and whatever the command I had, and I signed it and I passed it in the cookie, and I was able to get a command execution, and that way I could get an RC on server. So again, the same thing here, that not stopping at the first vulnerability itself, like just reporting, hey, your secret token is leaked, rather showing the impact of how we can actually get an RC using that. So it's more about just thinking bigger and figuring out connecting the dots where I can lead this object injection to stuff. And now in the earlier SSRF topic, we talked about this snippet, and it was vulnerable to SSRF and an LFR using just the relative path, and you will be able to access it. But lastly, it also allows us to open a command, a sub process, and we can execute our own command. So if we pass the first character as pipe to open function, we can actually get a remote code execution. So this code snippet here, the simple code snippet, is actually vulnerable to RC as well. So yeah, that's about RCs, SSRFs, and XXs. Now we will talk about something rather less talk, that is reverse proxies. And for that, I would like you to have some kind of stretching of your legs, because it's really interesting topic. And for that, I will pass it on to Rahul. On to you, Rahul.
Okay, so thank you, Harsh, for your great case studies on remote code execution. I hope you guys can see my screen, and I hope I am audible as well.
Yes, you are.
Okay, great. Okay, guys, so we have arrived to our last part of our workshop, which is reverse proxies, your entry point to hack a multi-layered architecture. So the agenda for this part of the workshop would be, we are going to look at some basics of reverse proxy. We are going to look at what are the common misconfigurations that we get to see in a reverse proxy based environment. And we would see at how some of the different servers process the URLs and all. And finally, we are going to see how different servers work in conjunction with each other, and how there could be some inconsistencies which could lead to some vulnerabilities. So what happens is, when a client makes a HTTP request to a server, which he thinks actually is the destination or the backend server, the request first hits the front-end server, which is also called as reverse proxy. In this example, it is Nginx working as a reverse proxy. So when Nginx receives this HTTP request, it is actually going to process the URL and route it to the correct destination servers, since there could be multiple destination servers. So based on the URL path or maybe the host header, it is going to route it to the correct destination server. And finally, the response which comes from destination server is also relayed via this reverse proxy back to the client. So web servers like Nginx and Apache have configurations which consist of various rules. And these rules, just as I told you, are based on either the URL path or the host header. And based on these URL path or host headers, prefix or suffix or maybe regular expressions, the request is proxied correctly to the correct destination server, destination or the backend server. So basically, rules are deciding the final routing of the request to the backend server. So in modern architectures, when we have multiple microservices behind the reverse proxies make it possible to route your URL path or the host header to the correct microservice. And also, since the response is also relayed via the reverse proxy, it could also be used to cache some static contents like CSS or images or something like that. And since we have now two servers involved, which is the front end and the backend server, which could be running on completely different web server technologies, because of this inconsistencies that could occur in these servers, there could be some vulnerabilities or misconfiguration that arises with them. So these are some of the common misconfigurations that we get to see in the reverse proxy based environment, which is web root based path traversals, server side request forgery, and access control bypasses. So let's learn about path parameters in Java-based server. So similar to query string, which we usually see a lot when we browse some applications, some website or applications, we have got something called as path parameters in Java-based servers, and it is delimited by this semicolon. So for example, if you have a URL path, something like index.jsp, semicolon x equals to 1, semicolon y equals to 2, it consists of two path parameters, which is x and y with the values 1 and 2 respectively. And also having this extra semicolon at the end of the file won't affect the loading of the file. And this index.jsp semicolon would still return the contents of index.jsp. So we had a look at this path parameter in Java-based servers, but let's just talk about a specific Java-based server, which is Tomcat. So when Tomcat receives a request from client, it is going to parse the URL path in the following manner. So first of all, it is going to remove all the path parameters, and then it is going to URL decode the URL path, and finally it is going to normalize the URL path. So in this remove path parameters method, what it actually does is it begins from this semicolon character, and until the slash, it is going to remove everything. So for example, if we have a path like /xyz semicolon test equals to 1 /index.jsp, it is going to remove everything beginning from this semicolon until the slash, which means just before the slash. The slash is not removed, and the path becomes something like /xyz /index.jsp. Similarly, if we have nothing after the semicolon or the path parameter, it would simply remove the semicolon itself, and we would end up with /xyz /index.jsp. The next step is the URL decoding of the path, and finally it normalizes the path if it contains any unresolved paths like .. slashes or maybe multiple slashes. So let's look at an example configuration of Nginx as a reverse proxy. So this is an example configuration in which we have got this location directive, which says /app1. So by default, the location directive matches the prefix rule, which means that any URL path which begins with /app1 would be proxied to this internal or the destination server. So any request with /app1 is going to be proxied to this server. And also, since this is a prefix match, if I do something like /app1xyz, it would be proxied to internal.app/xyz. So this is another example of Nginx configuration. And instead of default prefix match, it is using a regular expression. So we are looking for a URL path which begins with /app2 and /anything.jpg. And finally, we are proxying it to this internal host in /app2 directory. And this $1 here actually means this regular expression capture group, which means anything.jpg. So what happens is, if I make a request to something like /app2 /xyz.jpg, it would be proxied to internal.app /app2 /xyz.jpg. So let's look at how Nginx processes the URL when it receives it. So before matching the rule, Nginx is going to URL decode the path, and it is going to normalize any unresolved paths. And once it is done, it is then going to look at the configuration, the location directive to match the rule. And another thing is that Nginx simply ignores the URI fragment part that is beginning from hash to the end. And also multiple slashes here becomes a single slash. And the most important one here is that if there is a root trailing slash which is missing in the proxy pass argument, unprocessed URL path is sent to the proxy server, which means, for example, in this configuration, we do not have this trailing slash after the host. Even though Nginx would process the path before matching the rule, but once it has matched, it would send whatever the unprocessed path was to this destination server or the backend server. So this is an example of an environment where we have got Nginx as a reverse proxy and Tomcat as a backend server. So we have this very simple prefix match rule, which says if the path begins with /app, it is going to proxy it to this internal Tomcat server in this public directory. So which means that if I do something like site.com/app, it is going to proxy it to this backend server, which is internal.app port 8080/public. If I do something like app XYZ, it is going to again match the prefix rule because it begins with /app, and it is going to proxy it to this internal host /public and whatever after the prefix rule. So suppose there exists some kind of unauthenticated internal APIs or path or some files, or let's say we have got a Tomcat manager running with default credentials on the backend Tomcat server. But we know that this Tomcat server is actually not exposed and it is running on a local interface. But if we try to use this common or the legacy part traversal techniques, it is not going to work here because we know that first of all, Nginx is going to process the path. And if it sees something like /app/dot/slash, it is going to normalize it, and we would end up with this slash. And when it tries to look for a rule for the slash, it is not going to find one, and our request would not be proxied to the Tomcat server. And similarly, we cannot use the URL encoding versions because Nginx would then URL decode and then normalize. So let's welcome semicolon or dot slash, which is the new dot slash of Tomcat. So the exploit for this would look something like this, but let's see actually how it is working. So when an attacker makes this request, which is site.com/app/dot/slash and some secret API/users. So what happens is Nginx is going to look at its configuration. It sees that, okay, the URL path begins with /app. So it is first going to process it. So it is going to URL decode it and normalize it. But there is nothing to URL decode or normalize because it is not dot/slash now, but dot/semicolon/. So dot/semicolon is just another directory name for Nginx, and it has got no special meaning. So it is not going to normalize it as well. So therefore, we match this prefix /app rule here, and our request or everything after this prefix match would be proxied to this destination Tomcat server. So we would make this kind of request, which is internal.app port 8080/public, and whatever is appended to this /app. So now when Tomcat is going to process this URL, as we learned earlier, it is first going to remove the path parameters, which means that in this case, since there is nothing after the semicolon, only semicolon is going to be removed. So we would end up with something like this, which is now dot/slash instead of dot/semicolon. Next step is URL decoding. So again, there is nothing to decode. And finally, we are normalizing the unresolved path. So in this case, we would go one directory back because there is a dot/slash here, and we would end up in secret API/users. So now the response of internal app port 8080/secret API/users would be returned to the attacker. And that's how this Nginx and Tomcat misconfiguration occurs. So now Harsh is going to show you some other misconfigurations that occurs in different servers when they're used in conjunction. So over to you, Harsh.
Thanks, Rahul. 1 second. All right, so let's get started. Rahul has talked about nginx and how it processes its path, and how it works in conjunctions of multiple servers like Java based servers like Tomcat, for example. Now let's see how it could have misconfiguration in its own. So here we have a simple configuration that is looking for /API prefix /API, and it is passing anything after that, like it is proxying it to an host which is not publicly accessible, that is an internal host, and within that internal host it is passing it to this public API path. So now looking at this, suppose if we somehow get on the root of this internal host, we can access other files. Right now we can only be in this path only. So what if we can do some kind of path reversal here, which allows us to get into the root and other parts of the internal host that would allow us to get escalated access. So that's what's the issue here, is that when nginx sees /API, it directly matches that rule. Like for nginx, it is not necessary to have a slash here or anything like that. It just matches the prefix rule, and we don't have a trailing slash here. So what if we pass something like /API // Now when nginx sees it, it is just a directory name for it, like API // There is no slash in between to normalize it. So it will match the rule this /API and proxy from this dot to the user. So // internal API /user to this URL. And what we will get at this argument, it will be something like /public API // internal API /users. Now when this internal host, it could be nginx or Apache or any other, or maybe Tomcat or any other server, it would start its processing, and as soon as it sees // it will normalize it. So it will go one directory back, that is in the root, and within the root we will go into the internal API, and assuming that it has some kind of sensitive information, we can exfiltrate it. Now we didn't have access to it, we only had access to public API, but now we can access internal API. So just not having a slash shell led to this path traversal, allowing us to get and bypassing the access control limits. So this is one of such misconfiguration. Now we will see another misconfiguration. So for now, till now we were looking at the proxy pass directive that is proxying to another host. Now we will look at something called alias. So what is an alias? It allows us to, instead of passing the request to the another host, we will make use of it to search within the file system. So it could be used to serve static files like JavaScript or images and stuff. So the use case here is simple. If I pass /static/image.jpg, it will go into this directory, that is this, and append whatever it received here, image.jpg, and look for image.jpg. If it's available, it will serve its content, but if it's not there, it will serve 404. Quite simple, but it has its own issues. So let's have a look. Now we looked earlier that it only nginx only look for prefix. So we have /static and we don't have a slash again here. And this is the file system path, and we have a slash here. So suppose it was a Python application and it's serving the static files, the JavaScript images files, using this static route and looking at within this this directory path. What if we pass something like /static /settings.py? Now, as we talked earlier, it will look as any other directory name for nginx, but when this is passed to this file system directory, it will become something like /home/app/static/dot/settings.py. Now, when file system says, okay, I need to go one directory back, that is within the app directory, and now I can just access settings.py. And if settings.py is available, which we are assuming that this is a Django based or Flask based application, and we have the settings.py, which could have routes or any other sensitive stuff, we can actually access it. So we can do a path traversal to the web root. Now, this raises a question: why not to the root of the file system? Like, why don't add another // and go to the root of the file system? So the reason for that is, as soon as you add another // here, right, you add dot dot slash here, it will become slash dot dot slash, and Nginx will normalize it, and that won't match this rule static, because now we will end up in root. So we will never match this rule, and hence that won't work. So this is another of such misconfiguration, and this is actually very common, and we have found this in some bug bounty sites. Due to some time constraint, we won't be able to show you them right now. So now we will look at Apache, which is also a very common server used as a reverse proxy. So a simple configuration for Apache is something like proxy pass slash, like it takes 2 arguments. First, the location you want to check it on, and the host you want to pass this request on. So unlike Nginx, Apache actually enforces us to have a slash here. So if you pass slash app, you make a request to site.com/app, it will actually add slash by itself. It will make a 302 redirect, and anything after that will be appended after this slash. So this legacy tricks that were applicable for Nginx data slash won't work here in Apache case, but it has its own issues. So let's see. So before jumping in its own misconfiguration, let's look at some interesting feature and how Apache processes its request. So just like Nginx, it will start with URL decoding, normalize the path, and finally check for the location rule. And it will Apache actually have have a special meaning for multiple slashes when they come in the middle of path. If they are at the start of the path, it's actually not a problem. It will count it as a single slash. But when it comes within this middle of the path, it will count it as an individual directory. So you are looking at this, you see, okay, there's 2 directory, but actually there's 3 directory. That is, 1 is here. So that is a very interesting behavior with Apache, and we will see how we can abuse it for our advantage. So can you follow any vulnerability here?
It's just to notify you that we have 10 minutes left, so you know.
Yeah, sure thing.
Okay.
All right, so let's jump into it. We have a lot of time, and okay, so this configuration actually, looking for anything that starts with it's a regex check, and it is looking for anything that starts with /img, and it's looking for anything here. Let's pass it on to here. But you see, there is no trailing slash, so we can actually append to the host part of this Amazon AWS URL, and we can use something like @evil.com or .evil.com to make requests to our controlled domain, and that's how we can actually do an SSRF. And Nafi, who is a well-known bug bounty hunter, actually found something similar to this. So yeah, that's one with Apache. And here's an example of that same misconfiguration, and we get a forbidden if we access /a private, which is a directory check here. It won't allow any access to a private if it's not coming from a local IP range. So we will use of this SSRF to access this /a private, and we were able to get its response back. Now we have talked about Apache's processing. Now let's see how Apache and Nginx work in together. So Nginx as reverse proxy and Apache as backend. So we have a very simple configuration where that is looking for slash, and it will pass anything to this internal Apache host. And we have another directive here that is blocking access to protected Nginx labels. So the use case is very simple. Once again, the use case is quite simple here. If we access /protected, it will serve a 403 forbidden at Nginx level. It will never make it to Apache. But if we access anything else, it will make it to Apache, and whatever response we get it to it, it will serve using Nginx. But this could be bypassed, and that is using /protected//. Now remember how we have a special meaning for this. Let's see how actually it works. Let's see what happens under the hood. So we have this Nginx instance that is blocking access to protected, and we get a 403 forbidden at Nginx level. Now, if you look at the configuration, we don't have slash here, and as Rahul talked earlier, that we can actually if there's no slash here, whatever we pass it onto here after processing, it will send an unprocessed request to the internal host. So we will use of this two misconfigurations here to access this protected directory. So what if we pass /x//? Now it will match the rule slash, and it will pass it unproceded because there's no trailing slash here to the internal Apache host, and it will receive this and serve its response. Okay, quite simple. Now what if we do /x//dot//? When we do this, Apache Nginx will, okay, I need to normalize it, and I don't have any special meaning for //. So the rule, sorry. Yeah, so the rule here is quite simple. It will look for one directory back that is at the root, and we have a rule check for this slash, and it will proceed to this Apache instance. Now it will send because we don't have a trailing slash here, it will send it unproceded to this Apache instance. Now when it comes to Apache instance, as we talked earlier, it has a special meaning for // when it comes in the middle of the path, multiple slashes coming in the middle of the path. So when it processes this request // it will go one directory back, but because this is an individual directory, we still end up in the X directory, and we would be able to get X content directory response back using Nginx reverse proxy. So what if we pass /protected // ? It will pass as it is to /protected // to Apache instance, and it will do a path reversal, and we will end up in protected directory, and we will be able to get its response back. So I do have we are actually on time constraint, so I will go and partially show it to you. So this is served using Nginx, and just like protected, we have an admin directory here that is forbidden, and it is served at Nginx level only. Now, what if we access anything else? We get a response from Apache, but so it seems like there's a reverse proxy at Nginx and Apache as the backend server, but the admin route is blocked at Nginx itself. So we make use of that exploit, and we would be able to get its response back. Welcome to admin panel. And that's how it works. So that was all from our side. We have talked about SSRF, XXE, RC, and reverse proxies. And these are some references. Of course, this all awesome work is done by many great researchers, and we have linked all of them to this. And muchas gracias. I'm not sure if I pronounced it right, but yeah. And let us know if you have any feedback. And with that, thank you for joining us today, and have a great night.
Okay, thank you very much. Any questions? ¿Alguna pregunta, alguien? Si necesitan ayuda para decir la pregunta en inglés, acá estamos.
¿Se podría tener la presentación?
They're asking if they can have the presentation, the videos or the slash you show.
Yes, actually, like as I mentioned in the chat earlier, that we'll be sharing the Git repository that will have the setup for the labs, so they can set up the labs locally on their own machines. And also we'll be sharing the slides there, so they can go through the slides and work their way out of it.
Ok, thank you. Van a compartir el link acá en el chat. Igual el video está disponible en la web del Ekoparty.
Muchas gracias.
Your video is going to be available in the Ekoparty website.
Yeah, sure. So they can also, go through it when they want to, right?
Yes. Okay.
Perfect.
Thank you very, very much for giving your workshop. It was good.
Yeah. So guys, like I just want to mention that, this was a 4-hour long workshop that we tried to shrink into 2 hours. And we tried to deliver most of the content that we could. So yeah, that is pretty much it from our side. Thank you all for being a very great audience and listening to us. Also, we have a new initiative that is a YouTube channel that is called HTTP Void. So we are actually posting like a lot of technical content for guys, for the audience to learn from. So please go ahead and subscribe or make sure that you have a look at it, because there's already 2 videos that we have shared, and we'll also be sharing something that is part of the workshop, and we'll make a web series out of it. So anyone who's interested into web and want to learn something around web and security can directly go ahead and check out the channel. So yeah, guys, I just want to thank you guys for being a very good audience and listening to us. It was a wonderful experience speaking at Ekoparty. Thank you all.